Hi, my name is Bruno and I'm a technical educator at the Web3 Foundation. Starting with version 0.8.0 of the Polkadot source code, three different chains share this source code: Kusama, Polkadot, and Westend, the testnet for Polkadot. So how is it possible that one blob of source code, that one repository is powering three different chains? And how can it be that changing the resulting binary's name, so when you compile the program and get a executable program out of it, how is it possible that simply renaming this program will run a different chain? So for example, if you compile this source code, you will get a program called Polkadot. But if you just rename this to Kusama, you will suddenly be running the Kusama chain. What's going on here and how can this be? Before going further into this video, which is just a little bit technical, I recommend you familiarize yourself with the concept of substrate-based chains and Polkadot in general. Both of those videos and articles have been linked in the description below, and the sidebar of this video, if you hover up in the top right corner and hover over the little eye icon, you'll find links to those videos over there as well. So I recommend you spend the next 15 minutes looking over those two before diving in with the rest of the content of this video. When you compile a substrate-based chain, you end up with two things: a WASM blob and a binary. A binary is an executable file, a program on your computer. The WASM blob, on the other hand, is a blob of code that contains the logic, the runtime logic of the chain itself, and it's what allows us to have forkless upgrades. For more information on forkless upgrades, please see another linked video in the sidebar or in the description below. This Polkadot codebase, this single repository of code, is currently configured to produce three different WASM blobs during one compilation process. And I can actually show you this right now. If you look into the source folder of that repository after compilation, you will find that it actually contains, let me show you. So this is the Polkadot 089 folder. So this is the 0.8.9 version of Polkadot's source code. And if you go into target, which contains the build artifacts, so the compiled code, and open this, and if you go to release, that's the version of our compilation that we used, so release mode, you'll find here under wbuild, the wbuild folder contains the WASM blobs that were built. If you open it, you'll find that it has three different folders: Kusama runtime, Polkadot runtime, and Westend runtime. And each of those, if you open it, has this file Kusama runtime compact WASM. So every one of these folders contains the appropriate WASM file for that particular chain. But if we check the folder a little bit up and look into target release, you will find that it only has one binary in this folder. So this binary is called Polkadot. That's the one program that we got. We don't get three binaries. We don't get Polkadot, Kusama, and Westend. We only get Polkadot. So what's going on here? How can this one binary, this one program, run three different chains depending on what you set as the chain that's running? And even more mysteriously, how can it run a different chain if you just rename this binary into something else? So what's actually going on here is that the binary contains the logic of all three chains at once, but some of the functionality of some of these chains will remain untouched based on the chain specification file that is being loaded by this binary. The chain specification file tells the chain which runtime modules to run, which settings to use, and so on. And so you can think of it as a branching logic inside of the binary, which will simply disable parts of the code based on that chain specification that we have defined for this chain that we are running. And the chain specification for each of these chains is generated separately during the build process by each of these chains' runtimes. Now, every chain's runtime is defined in its own crate. That's like a Rust module, if you will, and they all share some common functionality through the common crate, a Polkadot runtime common crate that is common to all of them. But they have this other functionality built on top, which is either enabled or disabled based on the chain specification that has been loaded into the program. Now, if you're thinking what a waste of computer resources to have one binary that contains code that we never use in the case of two different blockchains that we are not running. If we're just running Polkadot, why would we contain the logic for Kusama and Westend as well in our program? You're partially right, but the selling point here is that right now it's worth it for the convenience. If we were to split up this code into 3 different code bases, while they are still so very similar, we would just create a lot of maintenance overhead and a lot of bureaucratic nightmare on the code level, because then we would have 4 repositories to take care of. So 4 because we have Substrate, which is the framework that all of these chains are based on, and then you have 3, 1 each for each of these chains that we're currently running, and if we power up another one, we would get another one. So at this point, it is much cheaper to have a little bit of extra code in the binary and 2 more WASM blobs that are only used conditionally, depending on which chain you run, rather than have 3 new code repositories on the side that everybody has to maintain in parallel. So what about that last mystery about renaming the binary file from Polkadot to Kusama and then it magically runs Kusama? Well, there's a Commands.rs file in the source code. You can look it up in the repository, and I'll link it below in the description. This file essentially looks at the name of the file that is running it, and if it matches Kusama, it loads Kusama. If it doesn't match anything familiar, then it will simply fall back to the chain flag. That's you run your node and pass in the chain flag, and the chain flag has a value of either Polkadot, Kusama, or Westend, and based on that flag, the appropriate chain specification will be loaded, and the appropriate parts of code will be enabled or disabled, and that's essentially how that works. If you'd like to be notified of when new videos like this come out or posts that describe these issues, please consider subscribing to this channel or subscribing to our .leap newsletter, which I'm going to link below in the description. The newsletter comes out every week or 2 weeks or so, and it will cover everything from core updates to code, to governance, to ecosystem updates, new tools that came out, new chains that are upcoming and connecting to Polkadot, and much, much more.